Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 9 from the October-November 2022 Pure Mathematics P3 paper from Cambridge International A-Level. And this question here is about vectors. And I'm going to go through this question in a bit of detail. So it says, with respect to the origin O, the position vectors of the points A, B, and C are given by these vectors here. So they have very kindly told us that the position vector of a point is from O to that point. So from O to A, 0, 5, 2, O to B, 1, 0, 1, O to C, 4, minus 3, minus 2. They might not have told us that the position vector is from O to a point, but this is what we should understand, that when they say the position vector of point A, they mean from O to A. The position vector with relation in relation to the origin, or with respect to the origin. So here we have the position vector of the points A, B, and C. It says the midpoint of AC is M and the point N lies on BC between B and C and is such that BN is twice NC. Find the position vectors of M and N. So what they're asking us to find here, find the position vectors of M and N, is basically if we just the position vectors of M and N, they're basically asking us to find the vector that takes us from O to M and O to N. Those are the two things they want us to find. The position vector of O to M and the position vector of O to N. Those are the two things that we have to have written down for us to have answered this question. All right, now I'm going to make a little diagram. With vectors, it's always very advantageous to draw a diagram to represent your your situation so that you can think about it in a more clear kind of way. So making a diagram in vectors is always something important. And as we have three-dimensional vectors, it's very difficult to actually draw an accurate diagram. So you can just basically choose any point you want for your point. So let's say I say, oh, my origin is here. And let's say I've called this the point A, this the point B, and this the point C. Okay, so let's say that's A and B. In fact, I need to make it a bit more, I think, because I have to join parts of BC. I have to join BC to AC. Okay, so let me put them over here to make it a bit clearer. So let's call this C and let's call this B. Okay, so half of AC and part of BC. Okay, so that will help us. So the vectors they've given us, I'm just trying to organize it so it will be able to be shown a bit clearer. Okay, so that's O to A. That's O to B. Doesn't want to stay straight for some reason. It wants to only be straight. I'll fix that. And this is O to C. Okay, so this is our position vector of A, O to A, which is 0, 5, 2. And this is the position vector of C, which is 4, negative 3, negative 2. And this is the position vector of B, which is 1, 0, 1. Okay, 1, 0, 1. Okay, so now they've told us that the midpoint of AC is M. So let me join these together. The midpoint of AC is M. So exactly halfway between A and C, we're going to call that M. And it says N lies on BC such that BN is twice NC. So when I join B and C together, N is on this line such that the distance between B and N is twice the distance between N and C. So it's kind of like this length is longer than that length. So this is like 2 parts, this is like 1 part, you could say. Okay, so from this information, we want to find the position vectors of M and N. So we need to find, I'll draw it in a different color. We need to find the vectors from O to M and from O to N. That's what we need to find. Okay, those are the two vectors we need to find. Okay. So how can we go about doing this? Well, what we can do is we can say, for example, I want to find the vector from O to M. Okay, from O to M, I can see that from O to M, want to go from O to M, I've got to go from O to A, and then I've got to go A to M. Okay, now A to M. Now we know that A to M is a half of A to C. A to M is a half of A to C. Okay, and so what we can do here is we can find what, we need to find the vector from A to C first. How do you find A to C? The vector from A to C. How do you find that? I want to go from A to C. I've got to go from A to O plus O to C. Okay, so if you think about it, A to C is going from A to O, which is minus this, and then from O to C, which is plus this. So basically, it's the same thing as saying O to C minus O to A. That's something that we should realize when we, have position vectors. So I want to go from A to C. I've got to go the minus this and then plus that. So it's the same as this minus that. So O to C is going to be 4, -3, and -2. Be careful with your signs here. Minus O to A, which is 0, 5, 2. Now that gives us what vector? 4 minus 0 is 4. -3 minus 5 is -8. And -2 minus 2 is -4. So 4 minus 8 minus 4 is a vector from A to C. So we can say that this is going to be O to A plus a half of A to C. Okay, which is O to A, we already know, is 0, 5, 2. 0, 5, 2 plus a half of A to C, and we've worked out what A to C is. It's 4 minus 8 minus 4. Okay, so we end up with our vector being, you got here 0 plus a half of 4, which is 2, and 5 minus 4, which is 1. Okay, because the half of minus 8 is minus 4, so 5 minus 4 is 1, and 2 minus 2, which is 0. So 2, 1, 0. That's the vector from O to M. Okay, so that's O to M. And we have to also find O to N. Okay, so we have to also find O to N. Okay, now to find O to N, okay, we can go from O to B and B to N. So you can say O to N is like going from O to B plus and B to N. Now, what do we know about B to N? Well, we can say that B to N is this, like, that's 2 parts, that's 1 part, that's 3 parts altogether, B to C. So B to N is like 2 out of 3 parts of B to C. Okay, so again, now we need to find what B to C is. So we can find B to C in a very similar way. We can say B to C is basically O to C minus O to B. O to C minus O to B. Why? Because if I want to go from B to C, I've got to go minus OB and plus OC. Minus OB plus OC, which is the same as saying OC minus OB. So we've got to take away these 2 vectors. So we have 4, -3, -2 minus 1, 0, 1. These 2 vectors, OC and OB. 1 minus 1, 0, 1. Now that's going to give you 4 minus 1, which is 3. And -3 minus 0, which is -3. And -2 minus 1, which is also -3. So we're going to have here O to N is equal to O to B plus 2/3 of B to C. 2/3 of B to C, which is 3 minus 3 minus 3. Okay, so in this case, well, let me just write it as B to C first. 2/3 of B to C. So O to B, as we know already from the question, is 1, 0, 1. You have 1, 0, 1 plus, and you have 2/3 of B to C. 2/3 of B to C is 2/3 of 3 minus 3 minus 3. 3 minus 3 minus 3. So now you have 1 plus, now when you multiply these together, the 3's cancel out, you're left with just 3, because you have 1 plus 2. And you have 0, again, the 3's will cancel out, you'll have -2. 2/3 times -3 is -2. And you have 2/3 times minus 3 again is going to be minus 2, but then you have to add 1 to it. So it's 1 minus 2, 1 minus 2, which is negative 1. Okay, so here we have our answer for O to N. Okay, so we can say O to M is 2, 1, 0, and O to N is 3 minus 2 minus 1. And those are the two answers here to part A of this question. Okay, so now moving on to part B, it says find a vector equation for the line through M and N. Okay, now we have to find the vector equation of a line. Now, the vector equation of a line is made up of two parts. Okay, it's made up of two parts. So you have the vector equation R is equal to A plus lambda B. Now, A stands for the position vector of any point on the line. And B stands for the direction of the line. The direction of the line. So we've got to find the vector equation for the line that passes through M and N, which would be this line over here on our diagram, the way we've drawn it. It would be a line that passes through these 2 points. Okay, so I have to have the direction of the line M and that goes to M and N, and it could be either way. It could be N to M, it could be M to N, and I need to know the position vector of 2 points on the line of 1 point on the line. Okay, now so the vector equation of the line, the first part tells you how to get to the line from the origin, and the second part of the line, which has this scalar with it, it could be lambda, it could be mu, it could be s, it could be t, it could be anything. They normally use lambda or mu. I'll just use lambda for now. So this is like a scalar kind of quantity, which you just, if you change its value, it will take you to different parts of the line. And B stands for the direction that the line is going in. Okay, so B is basically the direction of the line. And the A here would be the position vector of M or N. It doesn't matter, either of them, because they're both points on the line relative to the origin. Okay, so I need to find, I can say, let me call vector A, let me call it the vector O to M. I could even call it O to N, doesn't matter. So I have 3 minus 2 minus 1. So that's a position vector of the line. And my vector B here would be the direction of the line, which could be M to N or N to N, N to M, either way. Now, if I find M to N, it's the same thing as saying O to N minus O to M, as we learned before. If I want to go from M to N, I've got to go M to O, which is minus OM plus ON. So it's the same as saying ON minus OM. All right, so I just have to subtract these two vectors from each other. So that gives me basically O to N minus 3 minus 2 minus 1 minus 2, 1, and 0. So 3 minus 2 is 1, minus 2 minus 1 is minus 3, and 1 minus 0 is a minus 1. So that is the direction of the vector. I could even have it the other way around, N to M, in which case it would be 1, 3, and be minus 1, 3, and 1. Doesn't matter. And I can choose any one of these, as I said, as my position vector. I could choose O to M or O to N. I think I've just chosen O to M here. In fact, I've chosen O to N. It doesn't matter. It doesn't matter. It could be any of them. I've chosen O to N. I wrote down this one. I said O to M. I wrote down O to N. I can choose. It doesn't matter which one you do. Either of them. Okay. So when I now write down my vector equation of the line through M and N, I'm going to have a position vector of a point on the line, which is 3 minus 2 minus 1, plus lambda times the direction of the line, which is 1 minus 3 minus 1. Okay, that's a vector equation for the line. It doesn't say the vector equation, because I could have also wrote, for example, I could have wrote down R equals, I could have used the other point on the line, which 2, 1, 0. I could put 2, 1, 0 here. Plus, and I can put a scalar. I could use any letter for the scalar. And I could use, for example, the vector in the opposite direction. Minus 1, 3, 1. As long as it's parallel to the, it's going along that line. It doesn't matter which way it's going along the line. Okay, as long as it's going along that line, it's fine. So, this could be the answer. This could be the answer. I could mix. I could put this with that. I could put that with this. It really doesn't matter. So there's lots of different ways you can write the answer. As long as you have the position vector of a point on the line, and you have a vector which represents the direction of the line multiplied by a scalar, that is a vector equation of the line. So basically, any value of lambda that you need will take you to points on this line. So for example, when lambda is 0, in this case, when lambda is 0, I'm going to go to 3 minus 2 minus 1. Okay, so when lambda is 0, I'm going to go to, which is 3 minus, is O to n. Okay, so when lambda is 0, I'm going to end up over there. And then when lambda is 1, okay, then I'm going to have to go along the line. Accordingly, when lambda is 1, I'll have 3 plus 1, which will be 4, and minus 5, and minus 2. That's the point I'll be. And it will be somewhere along this line. Okay, so different values of lambda will take you to different points on the line. When lambda is 0, it's going to take you to what you have called your position vector, what you use as your position vector for your line, which was in this case 3 minus 2 minus 1 for the first line. All right, so that's how vector equation of straight lines work. Okay, and either of these two could be the answer. There could be variations of them, as long as this is a position vector of the line and this is the direction of the line going either one way or the other along the line. Okay, so there's part B done. Now for part C, it says find the position vector of the point Q where the line through M and N intersects the line through A and B. Okay, so now I'm going to just get some of that diagram and put it in this side so that we can look at it properly. Okay, so I brought the diagram over so we can see what we're doing. So it says find the position vector of the point Q where the line through M and N intersects the line through A and B. Okay, so I'm going to draw in red these other lines. Okay, in different color. So I'll draw a line going through A and B. We get it as a line, sorry. Okay, so I'll draw a line through A and B. Okay, that's a line through A and B. And then we have a line through M and N. Okay, with a line through M and N intersects the line through A and B. Okay, so it's going to be somewhere up here. Let me just... It's going to be somewhere up here. Good thing I didn't draw them like parallel. Okay, so there's going to be a point somewhere. You don't even have to draw it, to be honest, but you should realize that every line, well, so it's possible for them not to intersect, but we're not worrying about that right now. But this is the point. We want to find the position vector of the point Q. It's kind of out of my diagram. So we need to find how to get from O to Q. Okay, that's what we have to find. How to get from O to Q. That's our objective. Okay, we need to find this, O to Q. Okay, this is the vector O to Q that we have to find. Now, how do we find this vector O to Q? Well, it's where the line M and N and A to B intersect. So Q is the intersection. We didn't really have to even draw this, to be honest, but just so we can picture what's going on. The intersection of the lines A, B, and M, N. Okay, so now we know the position vector of the line AB and MN. Well, we found the position vector of the line MN already, right? So the position for MN, we found one form of it, which is, we could use either of these. I'll just use this one, 3 minus 2 minus 1, lambda 1 minus 3 minus 1. Okay, so you have 3 minus 2 minus 1, 3 minus 2 minus 1 plus lambda, just to make sure I don't make a silly mistake, lambda 1 minus 3 minus 1 plus lambda times 1 minus 3 minus 1. Okay, and the position vector of AB. Now, we didn't find the position vector of AB, but we know what the vector O to A is, and we know what the vector O to B is. What was the vector O to A? O to A was 0, 5, 2. Okay, so this is the vector 0, 5, 2. And O to B is 1, 0, 1. Okay, just to make sure. Yep. All right, so we can find the position vector of, or we can find the equation of the line through A and B. Okay, so we need the position, the equation of the line AB. So we need to find the vector from A to B, which is O to B minus O to A, as we've discussed already a few times. So O to B is how to get from O to B, which is 1, 0, 1, minus, and O to A is 0, 5, 2. Let's make sure I haven't missed out any minus signs here. Yep, there's no minus signs there. Okay, so you have 1 minus 0, which is 1, and 0 minus 5, which is negative 5, and 1 minus 2, which is minus 1. So that's the vector that takes us from A to B. Okay, and we can use the position vector of A or the position vector of B, it doesn't matter. So let's say our position vector for the line AB is going to be, let's take 052, plus we use another scalar, let's call it mu, times 1 minus 5 minus 1. So I need to know where these two intersect. Now they will intersect when they are at the same place. Okay, when they're at the same place. So when they're in the same place, what I can do is I can just solve these two equations kind of like simultaneously. So when they're in the same place, they will have the same position vector. Okay, they intersect when position vector of Mn is equal to the position vector of AB. Okay, which will be the position vector of Q. All right. So when they are equal, then that will be where Q is. So we can say 0, 5, and 2 plus mu times 1, negative 5, and negative 1 must be the same as 3, negative 2, negative 1 plus lambda times 1, negative 3, negative 1. Okay, when this is true, that's where we'll be at Q. So we can make three equations from this. From the top row, we have 0 plus lambda equals 3 plus, 0 plus mu equals 3 plus lambda. Okay, that's from the first equation. The second, you're going to have 5 plus, or 5 minus 5 lambda. 5 minus 5, mu is equal to negative 2 minus 3 lambda. And the third equation will be 2 minus mu is equal to minus 1 minus lambda. So we have three equations which we can use to solve these simultaneously. Okay, so what I think I will do here is I will use these two equations together first. Okay, and I will find the value of lambda and mu from those equations. Now we don't have to prove that they intersect. It says just find the position vector where they intersect. Okay. Yeah. So we have to just find the position. So we don't have to prove they intersect. If we had to prove they intersect, then we go through a step, which I'll actually show you, but we don't have to prove it. So when I find lambda, even just one of them, if I just find lambda or just find mu, I will have then done enough to solve the equation. I can then find the position vector of where they intersect. So let's go about doing this. I'm going to use some substitution. I'm going to replace this mu with 3 plus lambda. So I have 5 plus 5 times, instead of mu, I'll write 3 plus lambda. Okay, equals negative 2 minus 3 lambda. By doing that, we have eliminated the mu from the equation. We have equation just in lambda. So we have 5 minus 15 minus 5 lambda equals 2, or negative 2 minus 3 lambda. If we bring the lambdas together, you have minus 5 plus, or you have minus 3 lambda plus 5 lambda, which is going to be 2 lambda. And you have 5 minus 15, which is negative 10. Negative 10 plus 2 is negative 8. So you have lambda is equal to negative 4. So when lambda is negative 4, that's when they will intersect. Okay, so all we need to do now is put inside this equation here lambda as negative 4. So we'll use we know that the position vector of Q therefore is going to be 3 minus 2 minus 1 minus 4 times, we use the one with lambda in it because we found what lambda, minus 4 times this, which is 1 minus 3 minus 1. We have 3 minus 4, which is negative 1. And we have negative 2 plus 7, which is 5. Yeah, I'm talking about 5. That's negative 2 plus 12. That's going to be minus 10. Yeah, minus 2 plus 12, which is 10. Okay, which is positive 10. Okay, 10 minus 2. Sorry about that. I'm just messing up there. And then you have minus 1 plus 4. Minus 1 plus 4 is going to be 3. So minus 1, 10, 3. That is the position vector of Q. Minus 1, 10, and 3. Okay, so there's the answer to this question. Now, in this question, we weren't asked to prove that they intersect. They told us that they intersect. So I didn't have to find the value of mu. I didn't have to verify that that's where they intersect. I didn't need to go through all of that trouble, right? So when you have time restraints, you don't have to do that unless you have time to, if you want to make sure and check to see your answers are correct, because you could use it as a check if you want to. But if the question says show that they intersect and find their point of intersection, then you have to take it a bit further. Okay, so you would have to show they intersect by taking this value of lambda and finding what mu is from the two equations that you used. So I would take this minus 4. I'd say, okay, that means mu is equal to 3 minus 4, which is minus 1. And then I will check to see, do these values of lambda and mu work in the equation that I did not use for my calculations? So if you, for example, now replace mu with minus 1, you'll have 2 minus minus 1. And if you replace the lambda with minus 4, you'll have minus 1 minus minus 4. This gives you 2 plus 1, which is 3. And this gives you minus 1 plus 4, which is also 3. So because the value of lambda and mu that we found satisfies all three of the equations that we found, we know that they definitely intersect. Okay, so you can prove that they intersect that way. And then you can check your answer as well to see that you got the right position vector. When I put mu as minus 1 in this other equation, okay, put mu as minus 1, it should give me the same coordinates as I found here. Okay, so if I put mu as minus 1, I'll have 0, and I'll have minus 1 times 1, which would be minus 1, and 5, and it'll be 5 plus, it'll be 5 plus minus 1 times minus 5 is 5, so 5 plus 5, that should be 10, and 2, and you have minus 1 times minus 1, which is plus 1, so you have 2 plus 1, which is 3, so you can see we get exactly the same point, so we can be sure that we've done it correctly, right, by testing it in both equations. But as I said, if the question tells you that they already intersect, it doesn't tell you to show that they intersect, you don't need to go through this, other thing that I mentioned where you have to check, where you can check. You don't need to go through this at all unless they tell you that you have to show they intersect. Or if you have time and you want to, ensure that you've got the right answer, then you can go through that. Okay, so that's how we deal with question number, what was it again? Number 9 from this paper, all about vector equations of straight lines. Very important topic. Okay, so other questions from this particular paper can be found in the playlist that will appear at the top right of the screen at the end of this video. Other questions from the topic of vectors from P3 of Cambridge you can find in this playlist over here, and I'll also include the playlist for my Edexcel collection of vectors because it's very much related. P4 vectors in Edexcel A-level, the international A-level, is very much similar to the type of questions you get in Cambridge. So I'll put my playlist for that. There's a lot more questions there. You can browse through them if you want to. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon. Okay, so just one point before I end. A lot of students who did these questions, they didn't appreciate that the position vector of M is from O to M. They took it as A to M. They found what A to C was, and they found A to M as a position vector of M. No, A to C, the position vector of a point is always from the origin. So if you want to find the position vector of M, it's from O to M. The position vector of N is from O to N. Very, very important point. Okay, so I'll end with that. Thank you for watching. See you soon.